This is Radio Ecoshock with Alex Smith.
Some scientists and activists fear methane will rise up from the sea along Siberia, creating a heat emergency never seen before. But most major climate models do not include greenhouse gases from thawing permafrost at all. What is really going on here? Why is this formerly sleepy science so controversial? Scientist Sara Sayedi asked some of the world's top experts. In December 2020, Sayedi and 31 co-authors published the paper Subsea Permafrost Carbon Stocks and Climate Change, Sensitivity Estimated by Expert Assessment. That sounds like good material for us to know. Sayedi was educated in Iran, coming to Brigham Young University to complete her PhD in plant and wildlife science. From Utah, Sara Sayedi, welcome to Radio Ecoshock.
Hi, thanks for having me.
Why did you begin to assemble world experts on carbon at the bottom of the Arctic Ocean?
Well, as you know, as you mentioned right now, the carbon stored in that region and the feedback that it will have, and it has already on the global warming, is one of those things that we hear about quite a lot. And sometimes I feel like we hear a lot of mixed messages about the rate and magnitude of these feedbacks. But not only that, surprisingly, we see that in the main climate change reports or climate models, these carbon stocks and their feedback is kind of absent. So mainly because of uncertainty, of course. So I wanted to know, what do the scientific community knows about this system so far, and how do they think this system will affect climate
Sarah,
change
you
in the
made a
future?
preliminary presentation of the science at the American Geophysical Union in December 2018. Were you surprised to find a few scientists were strongly opposed to your work?
Yes and no. No, because in general, one of the main benefits of participating in these conferences and sharing our work is having the opportunity to discuss our research and get feedback from other scientists, which help us to improve our work. And sometimes it's opposition, which is part of that, and it's totally fine. Now, specifically in the case that you mentioned, I was maybe a little surprised by the critic that was mainly concerned about that, how the results of our study are going to be used and if they will be misunderstood as absolute answers, which I don't really think that was a fair critic, because, you think if you take anything out of context, that will become problematic. And there has been many studies that, have used expert assessment, and as far as I know, the results have been used properly.
To find out why these questions matter to the global future, why don't we set the stage a little? What is subsea permafrost?
Permafrost itself refers to ground that is frozen for at least 2 years in a row. Now, initially, permafrost was only on land, mainly in high latitudes, which was formed during the last glacial period. Now, after the last glacial maximum, as climate warming and the ice sheets and glaciers melted, the global sea level started to rise, and part of that terrestrial permafrost got submerged, which now we call that subsea permafrost.
So when the great glaciers captured so much of the world's water supply, there was more land extending into what would have been a smaller Arctic Ocean. Were plants able to grow up there? I mean, where does the carbon that you are measuring come from?
Not on the glaciated parts, obviously they didn't grow up there, but there was unglaciated regions where they were pretty productive and plants could grow on those regions. And also, this time that the carbon that we are referring here, it is also was accumulated way before that time. So it was over hundreds or even thousands of years.
Sarah, if there's liquid seawater above these Siberian shelves with the frozen plant matter on it, why doesn't the water just melt the frozen soil below it?
Well, it does. I mean, ever since this part of the terrestrial permafrost was become submerged, it is thawing. And this is obviously because the temperature of seawater is higher than the atmosphere. So it has been degrading, but the degradation rate is not really as fast as you might imagine, and I think it's estimated to be less than a meter a year.
And how long has this frozen carbon from plants been sitting there under the Siberian Sea?
Well, ever since it has become submerged, which was after the last glacial maximum.
So that's about 22,000 years ago, the last glacial maximum?
Yes.
Where is most of the subsea permafrost located? How big an area are we talking about here?
So, subsea permafrost can be found at the continental shelves of the Arctic Ocean and surrounding seas. The extent of it is estimated to be something around 2 million square kilometers, and a big portion of it is found in the East Siberian.
Right, I think this is important to note, that you can't go up through the Bering Strait and turn right and study subsea permafrost because there doesn't seem to be much carbon along the northern coast of Canada. You've got to turn left and go across the coastlines of Russia to do the research to find out what's really happening there.
Well, I mean, the main part is there. I mean, we do have still subsea permafrost in Alaska and other shelves, but yes, the very main part is in there.
What are the best estimates of how much carbon is stored in subsea permafrost, and how could that compare to human emissions? How can we understand it?
Yeah, so this was one of the questions that we asked from our experts. And so their estimate was that the subsea permafrost region currently contains about 60 billion tons of methane and 560 billion tons of organic matter. Now, to compare that with human emissions, we have released a total of about 500 billion tons of carbon into the atmosphere since the Industrial Revolution.
Well, obviously it would be a climate disaster if all that carbon emerged into our atmosphere in the next decade or two, but that's not happening. What are some of the factors that slow down the release from these subsea beds?
I think a good way to understand this is looking at the history of this system and see how it has changed over time. For one thing, these carbon stocks are distributed throughout the soil profile in the continental shelf, which can be hundreds of meters. So it takes a pretty long time for the temperature change in that deeper places. And even when it does, not all of the greenhouse gases that are generated because of either microbial activity or the gas hydrates, they cannot all reach the surface immediately. It's not really that easy. And even for those who do get to the seafloor and the surface, a lot of them will be consumed in the water column. So not much of that will get to the atmosphere. Also, we should remember that when we're talking about temperature change, we're only talking about a few degrees. So it's not like we're taking something out of the freezer and putting it in the oven. It's mostly like that. We are taking it out of the freezer and putting it in the fridge. It's a pretty low decomposition rate still. And also, another really important thing is oxygen. And these soils are very oxygen limited. So without oxygen, you don't really have decomposition. So yeah, it will probably take way, way longer than 2 decades for all of that carbon to get to the atmosphere.
Did your team of experts conclude that humans are forcing a faster release of carbon dioxide and methane into the atmosphere from low subsea permafrost beds?
Well, what our experts thought about the carbon stock's response to climate change is that subsea permafrost carbon response is pretty slow, and these stocks are pretty stable. And so the emissions that we are seeing today from that region, these are probably a result of climate change rather than this recent human climate change. However, they did mention that anthropogenic climate change can double these emissions in the future, but not really anytime soon. This might take really centuries to happen. So the group of experts in our study estimated around 40% degradation of subsea permafrost since the last glacial maximum. And for the loss of soil organic matter, their estimate was about 10% of that was decreased since the LGM. And that is all because of the natural climate change, the polar climate change that happened due to the change of Earth's orbit, which lead to sea level rise and change of the thermal regime of the permafrost.
Do the experts that you consulted think we are in an Arctic methane emergency or approaching one?
Well, no. Our conclusion was more that the methane release seems to be more of a result of a polar climate change. But obviously, that does not mean everything is fine. I mean, we are for sure at a greenhouse gas emergency, but it just is coming from our cars and power plants, not the subsea permafrost. And if we continue these greenhouse gases emissions, yes, we will maybe get to a point when reaching tipping points but this will maybe happen in centuries.
I think we should clarify one thing. Could you explain what is an expert assessment, and could you talk about how these are used?
When the big challenge about making decisions for our future is always uncertainty, especially where we have limited information or if we are experiencing new conditions that we're not really familiar for us, like this pandemic that we are now. So expert assessment is an interdisciplinary approach that is often used for risk assessment and decision making in the face of uncertainty. It is especially useful when we can't get the information that we need for decision making from the traditional science at the time. So using the knowledge of the experts related to the problem, and so these experts can be from diverse scientific backgrounds, we can kind of synthesize those knowledge and we can use that for informing policymakers. For sure, this methodology does not generate definite answers. It provides more subjective and holistic estimates that can be used for purposes of decision making or future research priorities.
Now, one of the better-known Russian permafrost experts is Dr. Igor Semilyatov from Russia's Institute of Natural Resources in Tomsk. Semilyatov often works with his partner, Natalia Shakova. They have led expedition ships to measure methane releases from the eastern Siberian sea shelf, and a couple of those research ships were funded by the Swedes. Sara, you have 5 or 6 Russian experts in your study, but not Semilyatov or Shakova. Why not?
Well, we did invite as many permafrost experts as we knew, including both researchers that you named. And, for many reasons, not all invitees can participate. This might be they don't like the expert assessment approach, or it didn't really fit their schedule, or maybe they never really opened my email. I don't know. But usually for this kind of research, around 20% participate rate is pretty typical. And of course, it would be better if we could have them and other experts in our team. But, hopefully in future assessments, there will be a higher participation rate and we can have more diverse experts.
Why would the assessments of the Arctic methane risk become political or even too hot to touch for some scientists?
Well, scientists are really trying to find the truth of everything. And their finding is not based on the expectations of public or politicians. The goal for scientists is to be objective as possible. And so, in my opinion, what happens is, especially with hot topics like climate change, whatever you say as a scientist, you might be upsetting someone. Some people may accuse you of being so alarmist and exaggerating, and then another group might accuse them of, hiding facts. I guess maybe dealing with this kind of feedbacks of social media or other platforms can just be a little frustrating, and maybe that's it.
You must be aware that a small group of scientists and followers encouraged by statements from Dr. Natalia Shakova believe we are approaching a catastrophic release of methane from subsea permafrost. The University of Arizona professor emeritus Guy McPherson suggested humans would go extinct very soon just because of this. We have the Arctic Methane Emergency Group, which includes seasoned ice scientist Dr. Peter Wadhams from the Cambridge Polar Group. In your work to collect expert opinion, did you come across this?
No, our group did not come to this conclusion because of specifically of subsea permafrost emissions, like something catastrophic will happen. But I like to emphasize again that subsea permafrost is one of the many carbon sources on the planet. But what I understand is that we are definitely in a greenhouse gas emergency, which is mainly because of humans. I don't personally think it will lead to extinction, but I do believe if we don't do anything about it, it will, and it already is in some regions, have really serious impacts on the society's economy and our health and well-being in general.
Yeah, to me this is the key question, which you raised earlier. It's not how much methane is coming out of the seabed, but how much actually reaches the atmosphere or can affect Earth's temperature. Do we know that yet?
This was one of the most important questions that we asked from our expert. This is really big uncertainties about how much greenhouse gas will get to the atmosphere and what the rate of this will be of this release from this region. Now, our experts estimated something around 140 million tons of carbon dioxide and 5 million tons of methane that will be released to the atmosphere each year from the subsea permafrost, this is kind of similar to the overall greenhouse gas emissions of a country like Spain. And it was estimated that if human-caused climate change continues, the release of these greenhouse gases can increase, but not abruptly again, but more like in centuries.
I really like this paper. It's worth reading by anyone, and anyone can read it. It's not too technical. But you had more than 20 experts look at possible impacts in the years 2050, 2100, and 2300. And for each year, you considered 3 possible emissions pathways employed by the IPCC. And those are RCP 2.6, which is the most optimistic. In my view, that's in the rearview mirror, really. But not everyone agrees with that. And you've got RCP 4.5, a kind of terrible middle ground. And then RCP 8.5, the worst case scenario with very high emissions, and various scientists say we're on that 8.5 pathway now, but we could change that. Could you boil your results down to maybe the best case scenario found by the experts, and then the worst case?
So for each of these RCP scenarios, different greenhouse gas concentration is defined for the future. And so models can tell us how the temperature of the atmosphere, the ocean, will change in the future under each of these scenarios and different timelines. Now, based on this information and many other factors that alter the carbon feedback of this region, the experts of our study projected how greenhouse gas emissions will change in the future. Now, the first thing that we can conclude from the experts is that for all scenarios, a net emission was predicting, meaning that the output of the carbon from this region will be higher than the input of carbon. And now for RCP 2.6 and 4.5, which, as you mentioned, are like a little bit more optimistic scenarios, it was predicted that this increase will probably be pretty low, between 0 and 10%, especially in the early years until like 2050 or even 2100. However, for RCP 8.5, which is business as usual, not only the amount of emissions was predicted to increase more, but also the uncertainty rate was higher for these estimates, indicating that more aggressive climate change goes we go, the more surprises we should expect.
Check out the Radio Ecoshock website. We're at ecoshock.org.
This is Radio Ecoshock. And from Utah, we are talking with Sara Sayedi about an expert assessment of methane and other greenhouse gases coming out of the subsea beds of permafrost, and most of them from northern Russia, but also in other parts of the world. There is some debate about whether a warmer north will encourage plants to capture more carbon, but your experts think subsea greenhouse gas emissions will be greater than northern plant life can capture. Is that right?
Well, yeah, that was not part of what our expert responded to, but the previous work showed that as much of 100 gigaton carbon is now in the plants of the Arctic and the Boreal region, but then 1,700 gigaton carbon is probably in the soils of this region. And so there is so much more carbon stored in these soils, in both the terrestrial and the subsea permafrost, that the plants can actually take, even if you double them. And especially in the later years where the emissions will go on, I think no matter how much plants you have, they really cannot just keep on with the emissions from the soil. So I think the only solution we really end up is with just decreasing human emissions before we reach the point that the Arctic vegetation will no longer be able to offset the permafrost emissions.
Your study notes several major Earth systems that could influence how fast these greenhouse gases will emerge, and it talks about changes in temperature, microbial activity, sea level, altered chemistry in the Arctic Ocean, and changes in photosynthesis associated with loss of sea ice or changes in nutrient availability. There could be tipping points in any of those. Sara, it sounds like a pretty uncertain picture, doesn't it?
Oh, yes, for sure. It's very uncertain. These are complex systems which are hard to study, hard to understand, and there's so many components and feedbacks of these systems that scientists are just learning about. I do like to point out, however, that that this system has been studied for a pretty long time. And of course, we don't have all of the pieces of the puzzle, but we do have some pieces. And I think what studies like ours do is that put that few pieces that we have so far and try to estimate at least a range of possible pictures that our puzzle might have. That can help us make better decisions today until we find more and more of that pieces, but that might take some time, actually.
Is there a difference between methane frozen in seawater, called clathrates, and subsea carbon in your expert assessment?
Yeah, so in our study, we wanted to know about all of the carbon pools that are in the Arctic continental shelf. And so there's like different kind of pools. So the first pool was the soil organic matter that has been accumulated in the soil profile of the continental shelf during hundreds of years, even before the sea level rise. Another pool of carbon refers to the sediments that are depositing into the subsea permafrost region during their years as a result of like Arctic river discharge and eroded coasts. And the last pool, I think that's the one that you were referring to in your question from the methane stocks that are like stored in this region. This can be now either gas or hybrid form, which is below and on the subsea permafrost.
Did your group of experts expect more danger from methane clathrates or other organic carbon in the seabed? What do we look for there?
So the way we designed our questions, we look at all methane stocks together, as I said, hydrates and gas together. So we didn't kind of like differ the methane sources. Like they were not asked separately in our assessment. However, it was mentioned by some of our experts that methane hydrates will not destabilize very easy because they're like really, really deep. And they have like, they're in this kind of good like stability zone where they have like in the kind of good temperature and pressure conditions. But overall, as you know, methane is much stronger greenhouse gas than carbon dioxide. And even though in our study the amount of methane emissions were estimated to be lower than carbon dioxide, but when we convert them to carbon dioxide equivalent, they did have a slightly more effect than organic matter.
We know some scientists suggest rapidly thawing methane clathrates pushed Earth into abrupt climate change in the long past. What did you find out about that in this review?
Yeah, so there's a lot of hypotheses about like the climate change that happened in long past. I guess one of those contributors are hypothesized to be methane hydrates. But even that really change took place like hundreds of years ago.
There's a relatively wide range of answers from experts for each case. Methane releases, for example, may be relatively little and slow, or could be a lot faster than we can tolerate. Why are there such differences among scientists who study subsea permafrost?
I mean, we had a pretty diverse group of scientists, both in the primary study region and their methodology of studying the system. And also when you look at like the published studies, which each cover different regions, there's a really wide range of estimates. So like putting all of those things together and like when you put these diverse perspectives together, on some issues there are like high agreement between our experts. Like for example, likely there's not going to be an abrupt emission in the near future from this region. But in some other details, like you mentioned, because of this patchy observation and uncertainties, we see like really wide ranges.
Sara, what do you think can be done to nail down expectations of greenhouse gases coming from shallow seas in the Arctic?
What was mentioned from almost all of our experts was in order to better understand the system and the possible feedback that it can have on global warming, we need more field observations. Deeper drillings are needed so we can study the old carbon and understand how the system evolved and what was the history of it. And another really important factor that seems to be ignored is the link between the terrestrial and the subsea permafrost and the possible thresholds that can be created. Like, for example, if the Arctic runoff rate increase and the sediment balance and other factors change, that might actually create new conditions that we're not really familiar with at all. And finally, I think really the better collaboration between different groups of researchers, industries, governments of the Arctic countries and just improving the sharing data, they will for sure speed the process of our understanding.
A lot more of the Siberian and other coastlines will be submerged as sea levels rise in this warming. Did your study add those new flooded lands when considering future releases? And if not, do we know how much frozen land will become new subsea permafrost?
We did ask the experts to include all aspects that can affect the future permafrost carbon feedback, which new subsea permafrost is part of it. But we did not separately ask that. But as far as I understand, if we consider the rate of sea level rise and the terrestrial permafrost degradation and coastal collapse, I don't think we should expect much new permafrost to be submerged and creating new subsea permafrost.
You're listening to EcoShock Radio for the world.
I'm Alex Smith. Get it all at our website, ecoshock.org.
From Utah, you've been listening to scientist Sara Sayedi talking about her new paper. You can find links to it at the Radio Ecoshock website. We are at ecoshock.org. Thank you for listening.